Ice World podcast. I'm your host, Rob Taylor. Antarctica is a continent defined by its weather. This is a landscape shaped by snow, ice, and wind. What is not immediately apparent is weather varies wildly across the continent. Altitude varies from 4,000 metres near the centre to sea level at its fringes. Latitude varies also, from the relatively northern island of South Georgia and the tip of the Antarctic peninsula to the pole itself. For human endeavour in Antarctica, understanding the weather is key. Sailors speak in hushed tones of the winds surrounding the continent, the roaring 40s, the furious 50s, and the screaming 60s. I spoke to the team of meteorologists and forecasters based at Rothera on the Antarctic peninsula to learn more about the work they do and the science that lies behind it. How many weather forecasters and meteorologists are working in Rothera at the moment?
There are currently 2, but there will be 3 across the whole season.
And what, in the main, is the job of, for example, the forecasters?
Our main purpose of being here is to support aviation. So we're only here during the summer while the planes are down. We are all aviation forecasters back home. So it's very specific to planes. We do sort of other stuff on the side whilst we're here, the more public weather forecasts and the boating forecasts and things like that. But our mainstay is for the plane. So there's a lot more to that than meets the eye. I know a lot of people, when they hear that you're a forecaster, they assume you're just forecasting whether it's going to be snowing or cloudy or windy or something like that. But there's actually, particularly with aviation, there's loads of stuff that I had no clue about before I first started this job. Like cloud amounts is important. Cloud base down to the nearest 100 feet is important. What type of cloud it is, whether there's going to be turbulence, what the visibility is down to the nearest 100 meters. What the wind is in like the nearest 10 degrees or the nearest 5 knots. It gets really, really specific. And icing in cloud and all sorts of interesting stuff. It's far more interesting, I find, than just the general public weather stuff.
So talk me through the process. You wake up quite early, and how do you go about constructing a weather forecast for that day for flying? So
in the college, they often talk about the forecast funnel, which is what, of course, we all use on a day-to-day basis. I sound sarcastic, but it's actually true. So a lot of it is just looking at the general picture. So synoptically, we would refer to that. So, you know, the charts that you get with the isobars on,
so
where the fronts are.
Look at a pressure chart, essentially.
Look at a pressure chart, and then we would try and decide, based on the air masses that we can see, where there's going to be precipitation and everything, decide where the fronts are. And that can give you a very broad idea of what the weather's going to be doing that day. It's mainly based on wind direction a lot of the time. It's really, really subtle. A southerly wind is generally bad here, tends to bring a lot of low cloud. Easterly wind is a very horrible crosswind direction. There's lots of nuances to each wind direction. So, yeah, when I first come in, the one unusual part of this job and the challenge is the fact that we have limited bandwidth. So normally back at home, you can flick through loads of model output. And by that, I mean fields that show you what the precipitation is doing all day, or fields that show you what the low cloud is doing, or what the wind gusts are doing, whatever like that. You can flick through it really, really quickly. But here, because the internet is so slow, you have to click on one frame, wait for that to load, snip it, put it into a PowerPoint, click on the next frame, wait for that to load, snip it and put it in a PowerPoint so that you can actually scroll through all of the frames.
Right.
On a PowerPoint, rather than if you were to try and scroll through it directly on the internet.
It would take too long and you wouldn't see the trends.
Yeah, you would be sat there waiting for each frame to load. And by each frame, I'm talking 3 hourlies.
But you need to see these in quick succession so you can see how things are moving.
Exactly, yeah.
Well, that's very interesting.
So that's a bit of a pain to have to do that. But it's just one of the things you have to do down here because it's quite limited. Another thing that we have down here is satellite imagery. That is one of the biggest useful things that we have down here. We have amazing satellite imagery down here, actually, because there are 2 main types of satellite imagery that we use. One of them is a geostationary satellite, which is stationary relevant to a point on the equator. So let's say a point over Africa, a a satellite will be stationary there, and as the Earth rotates, the satellite rotates with it. So it gives you the same bit of Earth steadily. But the downside of that is, because it's right over the equator, it's incredibly warped at the poles. So we can't use that down here. We can't use geostationary satellites. The other one, and the main one that we use down here, is polar orbiters, which are ones that circle the globe and they cross at the poles. So they're really useful here because we're obviously right next to the poles, so they cross us quite a lot. For somewhere on the equator, they might only cross once a day. So you get the different satellites for different areas of the world. So the satellite imagery that we have is of very, very high quality. But the only downside is we only get passes on the satellites for the first half of the day. And then after about midday, we fall into a big black hole of satellite imagery where we don't get anything until about 7 p.m. So when everyone's out flying and we're trying to figure out where the low cloud is going, we don't have any satellite imagery to figure out what is going on with that. In the morning, it's all good, but afternoon it's a bit of a challenge.
And all it would take maybe is 1 or 2 more satellites.
Yeah.
Or orbiting satellites that came across at maybe 2 p.m, 4 p.m.
Yeah, that would at least give you something. So we have to get all of those download all of that satellite data, download all of the model data, and then gradually just look at all of the different fields that you have. So there are so many different factors that go into a forecast. The temperature, the humidity, where the air has come from, what the wind speed is, what is that going to do to the cloud base? If the wind's too strong, it's going to lift up the cloud base. If it's snowing, it's going to bring the visibility down. But if it's really windy, that's going to cause blowing snow and bring the visibility down even further. So it's like a big recipe of all of these different things, and you have to pick and choose as to what ingredients you're going to have during that day and what that's going to come out with. So it's gradually figuring out what's going on, for starters, and then actually putting it into a format that people can use.
Why do we have forecasters in person in Antarctica? Would it not be as easy to have forecasters such as yourself in the UK, and you can look at the data online and you can look at maybe a webcam for Rothera? What's the advantage in having you physically here?
That's a very good question, but it is, and obviously Bass see the importance of it since they have 3 of us here every season. It is so important to actually be in a place to forecast, to be in the place that you're forecasting for. Back home, I also do forecasting for sometimes the place that I'm in and sometimes the place that is a remote location that I am not in. If you're actually there, you get such a better feel for the weather, what's actually going on. There's only so much you can get from an observation, rather than actually just looking out of the window and getting a bit of a sense of it. So from a forecasting perspective, actually being able to see it happen, you're connected with it so much more, rather than just hearing about it or seeing it in a code. It's like if you read about something on the news, it doesn't really affect you as much as if you're actually there and seeing it. It's that kind of physical presence of being there. So that side of thing for the forecasting. And one of the main things about being here is actually having a connection with the people that you're forecasting for to be able to do a good job. Because whilst we're forecasters, essentially we're also consultants, we're advisors. We're suggesting windows or saying, I think this forecast is really poor for this day, really good for this day. If you know what that means, if you know that means the guys at Sky Blue are finally going to be able to get out of there after being trapped there for so many days, and you have a sense of connection with the missions they're trying to accomplish, then it's just, you do a better job because you're more involved in it. And the people here value that a lot. I know there are some forecasting jobs where it's remote and the people just don't receive as good a service because they aren't as involved. They don't really know what's going on, and you'd forecast the same probably, but there's just something really to be said for being more involved in that process and actually being there with everyone. And they obviously value it as well, because being a co-pilot is a thing that we get to do down here. Hopefully you'll get to do that at some stage. I'm down to do one tomorrow.
That's exciting. So you're going as co-pilot on a plane?
So we have 2 types of plane here, the Twin Otter and the Dash 7. And hopefully I'll be able to go up in a Twin Otter tomorrow. So there's one captain, and then they technically have to fly with a co-pilot. They don't have to be a qualified pilot. It's basically just someone who sits in
person.
Exactly, a second person. And whilst it's a safety thing, it's also a fantastic recreation opportunity for everyone on base to be able to go on a co-pilot trip. They prioritise having the forecasters on first, because when you actually go and see the place that you're forecasting for, you get such a better sense of what the weather's going to actually do there. You can see something on a map and see the contours and see the orography, see where the nunatucks are, and get an idea of, okay, well, for example, a southeasterly wind at Sky Blue is going to bring up loads of low cloud from the Ronnie Ice Shelf, which is something that I know in theory. But when you've seen it, and you just know, you've seen it from the air, and you visualised all of that, you get a much better sense of it. Forecasting, whilst it's about theory and experience, a lot of it is, well, it is mainly experience, things that you've seen before, things that you know are possible, rather than just going off the theory and the model. The best forecasters out there can barely look at like all of the crazy model products, probably. The ones who really have an innate sense of what's going to happen, and who have been at a site for so many years, and they're like, this wind direction, I know what's going to happen now.
That's very interesting. There's obviously a lot more to it than meets the eye then, if that sort of instinct is so important.
Yes, and obviously all the model products are fantastic, and they're getting better all the time. They've even improved to a really big extent just in my time in the office, and I've only been forecasting for about 6 years. So they are definitely getting better, but you cannot put enough weight on the value of experience and the importance of looking out the window and actually going off what is actually there, and not getting your head too much involved in the model. Because there's model world, and then there's the actual world.
And they're not quite the same.
And obviously the main issue in forecasting is when those two do not tie up. And you're trying to figure out what's happening when the model is suggesting one thing and it is doing something completely different in reality.
So where are you going on your co-pilot flight tomorrow?
Hopefully through Fossil Bluff and then on to Sky Blue.
So what are Fossil Bluff and Sky Blue?
So, we're currently sat in Rothera, which is on just off Adelaide Island, off the western tip of the peninsula. Fossil Bluff is off another island that's just off the western side of the peninsula, but it's a bit further down to the south. It is sat in a sound that's full of sea ice at the moment. One thing that's an issue there in the summer is that melt pools can form on that sea ice, which provides a source of moisture for mist and fog to form. So mist and fog becomes a lot more of an issue at Fossil Bluff later on in the summer months. Sky Blue is actually on the peninsula itself. It's quite high up. It's around 5,000 feet or so. And it is a notoriously difficult place to forecast for.
Did you do the forecast for tomorrow? Or was that one of your colleagues?
I have done the forecast for tomorrow, but the way that we work it here is that we basically hand over in the middle of the day. So one person does the morning, one person does the afternoon, and then it flips over day by day, generally. And then we'll try and give each other a Sunday off. So the good thing about that is that you get a second pair of eyes on something. If you're looking at something and you're really not quite sure how it's going to go, and it's like with anything, you look at it for too long and you're just like, I don't know if I've gone into some sort of hole of confusion here and really led myself down the wrong path, and I need someone else to just do a sense check for me. So we get to do that with each other. So I did the forecast for tomorrow, and then Kat will have looked at it again this afternoon and given it a tweak based on her own thoughts and also updated models. So we get new model runs twice a day.
Driving force behind circumpolar winds. Can you explain the mechanism behind them?
Well, of course, in Antarctica, we're a landmass surrounded by sea. And that's a really important factor when we look at how the winds are around Antarctica. you think about what drives the forces around us, we have this air sinking off of the Antarctic plateau, driving down towards the coast, and you end up with these areas of low pressure developing around the coast, and then these spiral around the continent. It's great to watch if you see an animation of these pressure cells just moving round and round, and they generate these really strong westerlies. And because we've an area of pretty much uninterrupted ocean, they can really build up some strength as well, and hopefully driven by that polar jet as well, really pushes through. And it's a great thing to watch out for, particularly if you're forecasting for places like southern Chile, or even across towards Australia, or even down towards New Zealand.
While these present a challenge in the shape of rough seas, they also present an opportunity. The Clipper route between Europe and the Far East, New Zealand and Australia, took advantage of these winds for trade. This fell into disuse only following the rise of marine steam engines and the opening of the Suez and Panama canals. Today, round-the-world record attempts and races take advantage of these reliable, strong westerlies, much as their trading forebears did hundreds of years ago. Why don't we see similar winds at the North Pole?
Well, the North Pole is a little bit of a different story. So while we've got an area of land surrounded by sea in the South Pole and the Antarctic, in the north we've got an area of ice and open ocean surrounded by land. And so you don't get that same area of strong westerlies, you don't get that uninterrupted flow of lows, and you don't tend to get the stronger winds being pushed in from the central plateaus. But what you do get is you still get those westerly feeder air, so you still tend to get that jet forming through there. But with the air and the wind moving over things like land, there's much more friction involved, so you tend to get things slowing down just a touch more as well.
Further south than 60 degrees, however, winds are largely katabatic. These can reach speeds of up to 320 kilometres per hour.
So katabatic winds are those strong winds that drive down off of the coast, off of the continent, and they can help to form areas of low pressure around the continent. So these katabatic winds are pretty much masses of cold air running down the topography of Antarctica, being channeled through those glaciers and down through the valleys, and really lead to some pretty strong and pretty intense areas of strong winds.
How does weather in Antarctica differ from weather elsewhere on the planet? Obviously it's colder, obviously from what you've said it's windy. What else is different and unique about it?
So there are a few things that we get here which we don't see anywhere else. We see some fantastic optical phenomena, so things like halos and corona. We do see those in some of the parts of the world, but these are really fantastic ones. And we also see things during the winter, such as polar stratospheric clouds. Now these are clouds that are way up in the atmosphere and not made of ice crystals, but of different chemicals. And they're a really interesting thing to see. And they're a thing that you see really only at the higher latitudes, like us, or up in the northern hemisphere as well. And they're a bit of an indicator of different things going on in the atmosphere. You need really cold temperatures aloft for that. But back down towards the surface, it's even common in the garden, things that you take for granted in the real world, things like thunderstorms. We just don't get the depth of convection you need to see those clouds build up and bubble away. And so we can get a bit of convective weather in the summer when the temperatures start to pick up, but we just don't get the same height of cloud which you need to get that separation of charged particles to see the lightning form.
The image of a weather balloon being released is instantly recognisable. How the information from that balloon is collected and processed is less commonly known.
When we think about the weather, we're very used to seeing pictures in the newspaper and on TV of just pretty much a two-dimensional weather with surface pressure and areas of rain and those kind of things. But we actually have to think about the weather as more of a three-dimensional thing. And that's what the weather balloons are for. They are these helium balloons that we attach a radio sonde, and that's a device which has a temperature measurer and a humidity device, and it also measures the pressure as well. And so we send that up into the atmosphere, and attached to that as well is a GPS device, and if we follow where the balloon is, we can work out how strong the winds are and which direction they're blowing as well. And so we end up with this profile up through the atmosphere of how the weather is changing, so how the winds are changing, how cold it is, and just things like that, and where these areas of high humidity are, and things like areas of cloud. It's really a useful tool for the forecasters.
But how high does this balloon get to in the end?
So for us down here in Antarctica, we're looking at around about 27, 28 kilometres up. So really very high up. And so we send it off at the same time as everyone else in the globe to try and make sure that we measure the same atmosphere at the same time. We launch our weather balloons around about 8 o'clock in the morning. And that arrives at about 100 hectopascals, so around about 15 kilometres up, around about 9 local, which is 12 Zulu, which is about midday in terms of the GMT, and that's the way it works across the globe. So we all try and launch our balloons so that they reach this 100 hectopascal level around about 12 Zulu. So from us here in Antarctica, from everyone in the UK, from the States down towards New Zealand, we all launch our balloons with that same goal in mind.
So how many balloons are launched at midday GMT every day? I mean, is this 10,000 balloons worldwide?
It's a very good question. So probably not 10,000, probably at the most, perhaps 1,000 across the world, but more likely to be in the hundreds. For us in Antarctica, though, there's not many sites, which means that everything we do here is worth just a little bit more because there's not many observations that we make down here. So those weather balloons that we do one of those every weekday, Monday to Friday. They're just worth that a little bit more because there's just us down here around the coast, and we send those weather balloons up and get that information back to our friends up north.
Does that mean that the computer models for weather in Antarctica are less accurate than models elsewhere?
It's a really tricky thing to work out how we can model the weather around the poles. And there's lots of things that go into that. And one of the things that makes it tricky is the number of observations that we have. If you think about how many observations are made across the UK and across Europe, there's hundreds of these things that get sent through every hour. Whereas for us down here, there's a handful of observations that get sent through. And so it makes it harder to ground check your forecasts and to get those initial conditions. And it's just another one of those challenges of forecasting the weather in Antarctica.
There is widespread scientific consensus that greenhouse gases are affecting the climate of the Antarctic. 40 to 50 million years ago, temperatures were far warmer on the continent. Analysis of weather balloon data from the past 30 years has shown that the Antarctic atmosphere has warmed below 8 kilometres and cooled above this height. This pattern is the expected signature of an increase in greenhouse gases, such as carbon dioxide, that can be seen across the globe. However, the warming at 5 kilometres over the Antarctic during winter is over 3 times the global average. This means that even in parts of Antarctica where no warming has been observed at the surface, we are still seeing significant changes higher up. Thanks to John Law and Catherine Maguire for appearing on the show. You've been listening to Ice World, a podcast on behalf of the British Antarctic Survey. If you want to learn more about the survey's work in Antarctica and beyond, please visit our website at www.bas.ac.uk. Thank you for listening.